Hello everyone, and in this video we're going to discuss importing data from a CSV file in order to better understand the idea of indexing and slicing and basically wrangling with data in Python. Here we see my Jupyter notebook for this lesson. If you want to follow me on GitHub or get this IPython notebook from my GitHub, the link is below on the YouTube description section. So in this case, we want to take a practical example of where we have a given set of data and eventually want to do something with it, whether it be plotting it or doing some kind of mathematical analysis. So let's take the example of a ball dropping or some kind of object dropping. And you drop this object, say 15 times or n number of times from a variety of different heights. And you're interested in getting either a histogram of the data or maybe the drop time as a function of position. So what you do is you take your data and you record it in this CSV. So here you can see for, say, a position of 20 meters above the ground, you drop your object and it hits at 1.66 seconds. You do it again and it hits at 1.95 all the way up until you have 15 measurements. You then repeat the same procedure, but this time from a different height. So here we see we're measuring really kind of two quantities. One, the drop time, but also the drop time with respect to a given distance. So this data is stored in an array, which you can think of as a series of rows and columns, and that's why we're looking at this Excel file right now, where the columns are going to represent the drop times for a given position, and the rows represent the drop times across all positions. So in this video, what we're going to want to do is we're going to want to talk about how to upload this data and manipulate it using two methods. The first I'm going to discuss is by using NumPy's built-in CSV reader, np.loadtext, and then we're going to have an additional section where we're going to introduce the idea of pandas and using that to read in data. Please note that this is not going to be a video dedicated to pandas, but just as a way of introducing this concept. So we see that our data is stored in this kind of row and column format in a table. What we're going to be using to upload this data is this command given by NumPy, load text, which takes in a file name, a delimiter. A delimiter is a way a computer separates values within a text file as its main arguments, along with arguments dealing with rows that you might want to skip and columns that you want to use. We're going to be cognizant of these two additional arguments in this lesson because generally when you're uploading data with NumPy, it does not like dealing with both strings and numbers. So if we take a look at our CSV file again, we see that this first row of headers are going to be given by strings, and we're not going to want to have to deal with that. So we're going to skip that row when we upload it. So as usual, we're going to begin by importing NumPy as np, shown in this cell here, along with importing matplotlib, and the matplotlib inline command allows us to actually plot in line or plot on the screen the plot we're looking for rather than saving it to an external file. So if you remember from the previous video, what we want to do is we want to store quantities as variables, whether it be a number or a word or whatever. And arrays are going to be stored as a variable like any other quantity. So when we upload the data using this np.loadtext, it's going to store the data as an array. So here we can see that it's going to take in the argument of the CSV name, the delimiter, and the rows we want to skip. So let's just take a quick example where if we don't specify what rows we want to skip, it's going to throw an error, mainly telling us that, hey, I don't like dealing with these strings. What's going on? So to rectify that, we're going to specifically tell Python to skip the first row. And here it ran. You can see that the data is stored in this fall times array, and the size of that array is given by 15, corresponding to the rows of my array. And remember, this is going to be the nth drop time, and the columns are going to be representative of the different positions. It's often really useful to take a look at this, especially if we're not used to seeing things in a non-tabular format. It's rather abstract, and that's why looking at the shape of an array is very useful. This can be accomplished by using the command np.shape. As you see in this cell, I call it. And basically what that's going to tell you is the number of elements along a given row, followed by the number of columns. So we uploaded our data, and now we want to take a look at specifically how to access a given point. So we do this by something called indexing. So if I have my array here, I'm just going to comment this out, and if I print the array fall times, we can see that we basically have a matrix of numbers. Now, a matrix is a mathematical quantity. I might slip up and refer to an array as a matrix for some silly reason, but know that we're dealing with a non-mathematical entity right now that basically is storing information. So this information, it is the data. So along the first column, like we said before, we have the drop times for the first drop, followed by the second drop, third drop, and whatever. So when we want to call a specific element or row or columns from a given array, the first thing we're going to do is we're going to write the variable name that the data is stored in, which in this case is fall times. We then tell Python that we want to access something from that array using the bracket symbol. If I wanted to say access the third measurement, or rather the second measurement from the first column, what I would do is I would specify I want the second measurement, which in this case is going to be 1, because Python indexes starting at 0. So in reality, Python is reading this first column as column 0, followed by column 1, column 2, column 3, and the same thing with rows. Row 0, row 1, row 2. So we're going to index by first calling the row, which is saying, okay, I want the second row, and let's say I want the first position. So doing this, we see that it's going to give me 1.95, which is the drop time corresponding to the first position's second measurement. Again, if I wanted to say have 3, 0, this 3 is going to correspond to, well, let's think about it. It's going to start counting at 0. So 0 would be the first one, 1 would be the second. Therefore, in this case, we're going to the fourth measurement corresponding to the very first drop time. So again, uncommenting the section that we're getting the fourth measurement from the first position. I know I might sound a little bit repetitive by saying this, but again, it's to bring home this idea of that, one, we call indices by specifying first the row and then the column, and the fact that Python starts counting at 0 and not 1. Okay, great. So what we have now is a single entry. That does us a lot of good, right? We have this whole data set and we can only pull one single point. We can rectify that by using this column operator. which this column says to get every single element in a given row or column. So in this case, we see if I print my array, which I called fall times, and let's comment this out right now. The first drop times are along this first column. So I want to say that if I want to access that data to be able to have a histogram or something like that, I would use the colon operator that tells me to access every single element in this row. So we're going to get all the rows in this given column, the first column. Printing this and scrolling down, we see that we get exactly this first column of data. Now that we have that accessed, we can store it as variables. So if I wanted to say first position time, I could say that's going to equal the fall times of, I want all of the measurements for the first position, and there I go. If I wanted to, say, have a histogram, I could do plt.hist of first position times. Let me follow that with a plt.show, just so we don't have the output array shown. And here we can see a histogram of the data. Now, it's not really computationally efficient to call an array a new variable every single time, or rather a column of array a new variable every single time. So in order to prevent that, what we can do is we can just take in the argument fall times :0, run it, and for some reason it's not showing, and that's because I forgot my comma here. You need to make sure you have that comma there, or Python will not know what you're talking about. And if I run it again, we see the exact distribution. So let's just recap of what we learned. In this video, we learned the basic idea of how to input data into Python using the np.loadText. Remember, in that case, we don't want to read in header rows, which are strings, because it will throw the error. We also discussed how to index an array and get specific elements from that array by calling that array followed by the index of the row followed by the index of the column to get whatever specific data you wanted. Okay, well, that sums it up for this video. Like I said, the next video is going to show an alternative to the np.loadText option using the Pandas data science library or database library. And I look forward to showing you about that. Thank you very much.